People have joined. Welcome to our webinar. This is Migrating Data Workloads from SQL to Azure Synapse. Good afternoon. My name is Matt Safer. I'm a senior cloud consultant on the data team here at Atmosera Wintellect. I primarily work with clients, helping them either with their initial migration into Azure or to improve their existing Azure footprint. I focus on the data services within Azure. A couple of those are Azure SQL, Synapse Analytics, which we're going to talk to today, Databricks, and Cosmos DB. I also do training and webinars like this, and I'm a Microsoft certified trainer. First, let's talk a little bit about Atmosera and Wintellect and the core services that we offer. Like I said, we do consulting. That's where I spend most of my time, but we also do instructor-led and on-demand training. And since we've merged with Atmosera, we also are a CSP and provide managed services. We're a Microsoft Gold partner and a GitHub verified partner. You might be familiar with us even if you've never heard our name, because a lot of our employees have literally written the book on a lot of these topics you'll see here. I've got a couple of special offers to tell you about today before we get into the material. We, for new managed service customers, offer the first 3 months free. We also offer free disaster recovery setup when we start managing your environment. We also are offering a free half-day advisory session on Azure app development, DevOps, data and AI, or mobile development. And the last offer here might be most pertinent to this audience because we're offering a $10,000 credit for helping customers migrate from SQL to Azure Synapse. So if any of those interest you, you can sign up using this link. Don't worry about having to write this link down. This will be emailed out at the end. All right, we're going to go over the agenda to start, but before we do, just want to make a note of who this webinar is geared towards. This, in my mind, the audience should be familiar with SQL. It's primarily geared towards data engineers and those with some familiarity with Azure and maybe some familiarity with Spark, but that's not required. So first, we're going to go over what is Synapse Analytics and when we should consider it. We're going to spend a lot of time on the different components within Synapse Analytics just because there are so many different pieces, and it's important to understand what's available, and that's important for deciding how you should migrate your workloads into Synapse. Then we're going to get into a hands-on section. We're going to go over a very basic workload that runs on SQL, in this case like an SSIS package. And then we're going to talk about how we'd migrate that to Synapse and what it would look like over there. And at the end, we'll have some questions. All right, what is Synapse Analytics? I found this GIF. I think it's a good example of what Synapse Analytics is, the services that comprise it. Microsoft bills Synapse Analytics as a limitless analytics service. I think this is true. Ultimately, it's an amalgamation of many different services that existed separately within Azure. A couple of those are Azure Data Factory for orchestration, a couple different SQL architectures, which we're going to get into here shortly, and also Spark. Some things we're not going to talk about today that are kind of related and a part of Synapse Analytics are more the presentation layer. So we're not going to talk about the Power BI integration or any of the AI or ML services that can connect in. Okay, when should we consider Synapse Analytics? There are a lot of options on the market today, and I like to move customers towards Synapse Analytics when they're dedicated to Azure. They have a data team who has a Microsoft SQL background, and they want to expand out into newer big data technologies. They might be interested in getting started with maybe Spark or something like that. We want to consider the data and workload size, and normally we want that to be over 1 terabyte. When comparing Synapse to other database offerings within Azure, like Azure SQL, we see that Azure SQL offers up to 8 terabytes on the general purpose tier and 4 terabytes for business critical. So you can certainly build a data warehouse using those technologies. There's also a hyperscale tier that goes up to 100 terabytes. But we want to start thinking about moving into Synapse Analytics when we're about over a terabyte or so. Next, I'd like to talk about the workloads for Azure Synapse. And what I'm going to say right now is specifically geared towards a specific SQL architecture within Synapse, and that's the dedicated SQL pool. So OLAP workloads are very good for a good fit for Synapse, and it's definitely not for OLTP workloads. So you don't want to use Synapse for connecting in your front end of your application to do any processing. It could be good for ad hoc processing that's done in the background that then presents data that your application uses, but not for a direct OLTP data store. Another good use case is for a logical data warehouse. You shouldn't be using Synapse for, back to the OLAP workloads briefly. You shouldn't be using Synapse for small workloads, small reads and small writes. That's better suited to Azure SQL. And also, when you have workloads that are large, complex, and have a set volume, that's when they're a good fit for Synapse, specifically the dedicated SQL pool. But back to the logical data warehouse, this is a good use case for Synapse, especially the serverless SQL pool. This is when you have disparate data sources, maybe already landing on a data lake. These could be in Parquet files, delimited data like CSV, JSON, or unstructured data. This is where you'd use that serverless SQL pool to organize and present that data, maybe with some light transformation, and then present it. This gives you an advantage because you don't have to make multiple copies of the data. You can just use that serverless pool to present the data in different ways. There's a couple things you should know about Synapse, specifically the dedicated pool. You're going to be getting lower concurrency than you get with a traditional Azure SQL database. So that's another reason not to use it as an OLTP data store. So with Synapse, you only get a maximum of 128 concurrent queries, whereas SQL allows 6,400 concurrent workers and up to 30,000 concurrent sessions. Some other limitations or differences between SQL and Synapse is, while I say it's good for SQL developers because they're going to have a good understanding of the syntax, there are some syntax differences. That's well documented on all the Microsoft documentation pages for commands. It'll have a section that'll say, here's how to run this command. Here's how the syntax is slightly different for Synapse. But there are some other differences that aren't available within Synapse, and one of those is cross-database queries. With a traditional SQL server, you may have multiple databases and run queries that hit multiple databases at once, and that's supported on SQL, but it's not supported in Synapse. There's also no computed columns or indexed views. So a number of things, those are just a couple of examples. All right, we're going to get into the components here. We're going to start with the storage layer. Synapse Analytics is built on top of Azure Data Lake storage. Azure Data Lake storage is built on Azure Blob storage, but it's specifically designed for analytics. And what that means is that you're going to get enhanced performance and for analytical workloads, and that's specifically achieved through the use of hierarchical namespaces rather than a flat namespace. And you get a flat namespace with a traditional Azure Blob account. So this hierarchical namespace allows for improved management operations. And also with the data lake, you get a little bit better security with POSIX permissions on directories or individual files. You also get Hadoop compatible access with the data lake, and that's achieved using a upgraded driver from the traditional blob driver. You also get unlimited scale. So you never have to worry about adding hard drive space. You have what they would describe as exabyte scale, which is far larger than any data loads I've ever had to deal with. But ultimately, you never have to worry about expanding or adding hard drives. It's highly secure. By default, it's encrypted at rest, all your data on the data lake. And it also provides the option, if you want even more security, perhaps by bringing your own key. So that would be like a double encryption scenario, because it's by default decrypted or encrypted with Microsoft's key. You can bring your own key and double encrypt it if you want. You also get cost optimization that you get with any blob storage. And this is sometimes known as data lifecycle management or different storage tiers. By default, your data will be in the hot tier, so that's for actively used data. But you can also move data as it ages out that's not frequently accessed to a cool or archive tier. That'll save some money. All right, we're going to get into now the different architectures and engines provided within Synapse Analytics. We're going to start with the serverless SQL pool. Then we're going to talk about the dedicated SQL pool and also the Spark pool. So let's take a look at the serverless SQL pool here first. It's called serverless. Ultimately, serverless is a kind of a misnomer. There is a server, of course, associated, but it's not a dedicated server. It's on demand. It's similar to other serverless options within Azure, like Azure Functions and Azure Logic Apps. So if you're familiar with those, this is very similar. Sometimes this is referred to as SQL on demand. So the query engine is kind of brought to your data. This makes it very resilient to failure and also elastic. So it'll auto scale up and down as your demand varies. One thing to note about serverless is there's no local storage or ingestion capabilities. So it's basically for reading data only. The only data that is stored about your data is metadata. So you can create a database, you can create views, you can create stored procedures, but you can't create tables using serverless SQL. This is similar to Spark. If you're familiar with working with Spark, you create a meta store, which is kind of just a logical grouping of your data. So serverless supports views, stored procedures, external and temporary tables. One good use case is to expose data that exists on your data lake to reporting tools. It's a pay per consumption model, so you pay only for what you use. Here's some use cases, data discovery. So if you have a new data set that you don't know much about, you need to do some data profiling. Serverless is a good option. You land that data in your data lake. Your serverless pool is available. It spins up within, it can query your data within a second or two. Another good use case is that logical data warehouse I mentioned earlier, and also some light data transformation. So if you need to do a couple, simple queries on data, you can do that with this and present that. And I'm going to show that when we get into the hands-on section. All right, the next architecture is the dedicated SQL pool. This also uses a distributed query processor using that SQL engine, but it's a more structured architecture than serverless. Specifically the storage, how your data is stored. And with dedicated SQL pool, your data is distributed, and it's distributed between 60 different nodes, which we call distributions. And there are a number of different methods that your data from your tables is distributed. The default way is called round robin, and that's good for staging tables. Your data with round robin is spread evenly across the nodes. So it's good, like I said, for staging, but not very good for data that you might have to join with other data because the data movement would be required across joins. The second distribution method is a hash distribution. And with hash distribution, each row belongs to one distribution using a deterministic hashing algorithm. And the number of rows per distribution in your table then is going to vary. And that has performance implications. So you have to think about it when you decide what you're going to use for your hashing column or columns. Ultimately, you don't want a hot distribution where the majority of your data is on one distribution, because that will limit the parallelism for this MPP architecture. The hash distribution is very good for large fact tables. The last distribution method really isn't, well, I guess it's a distribution method, but it's called replicated, and that's where your data is replicated on each node, a copy of your table. So this is recommended only for data tables that are 2 gigs in size or less. and you are going to pay for the extra storage that it costs to store it on each node. That the replicated can be good for small dimension tables. The dedicated SQL pool, the compute abstraction used to describe your tier is called a data warehouse unit, or a DWU. These range from 100 to 30,000. And like I said, it's a compute abstraction, which is a combination of CPU, memory, and I/O. So scaling up and down within those tiers adjusts the performance linearly, but also the cost. I mentioned with this architecture, you have 60 distributions that store your data. And with the highest tier here, you'll get 60 compute nodes associated with them. The scale also has implications on the concurrency that you're going to get. Scaling can be done automatically. Not automatically. It can be done manually or programmatically through APIs. And so you can have it scale to respond to demand or schedule if you set it up that way. It also supports pausing and resume. So if you want to do all your processing in the morning, you can spin it up, do your processing, spin it down, and save some costs that way. Last thing I want to mention here is something called workload management. And this is the ability to fine tune your workloads within a dedicated pool. You can classify your workloads and assign them percentages of the available resources. So that's important when you're fine tuning your workloads, really nailing them down. You can really control your costs well if you can classify your workloads. All right, the last architecture is the Spark pool. So this is a compute method available in Synapse Analytics. Not going to spend too much time on this today because ultimately we're talking about SQL data loads moving into Synapse, but it is available. If you're not familiar with Spark, it's a unified engine for large-scale distributed data processing. It's very popular. It's very fast due to its in-memory operations. It's a clustered architecture, so there's a control node and worker nodes. To set up a cluster within Synapse Analytics is very easy. There's minimal configuration necessary on your part. You can configure auto scaling if you want. So as load changes, your cluster can scale up to complete that as quickly as you need it to. There is some warm-up time with the Spark cluster. It takes about 3 to 5 minutes for your cluster to spin up from being off. You have your notebook development, which you're familiar with if you have used Spark in the past. That can be, you can use Scala, Python, or SQL. You can run in batch or streaming processing. That's one of the things I personally like about Spark, is how easy it is to switch between the two. So you could originally code your processing in batch mode, and it's very easy to convert that code into a streaming architecture. Spark is platform agnostic, so if you have your own existing Spark code, it's easy to bring that into Synapse. Excuse me. There's also vigorous development going on within Spark. 3.1 was just released, and it was quickly added to Synapse. So Synapse is constantly keeping up to date with the open source development. All right, here's a table I put together with a feature comparison between the options here. So we talked about each of these different pools. With the serverless pool, again, it's good for logical data warehousing, big data discovery, ad hoc analysis. Dedicated SQL pool is more for your traditional data warehousing. Apache Spark, also good for data discovery. If you're familiar with Python or Scala, it's a good choice. Also, you have those connectors into some of the AI and ML capabilities of Azure. They have different cost models, so that's shown well here. In serverless, your build per terabyte of data read. Dedicated SQL pool, your build per hour as the pools are on. When they're paused, you're only billed for storage. Apache Spark, your build per minute when the cluster is on. Languages supported, T-SQL on both those SQL pools. On Spark, you got that Spark SQL, R, Python, Scala. We talked about the warm-up times. The auto scaling is there by default with serverless, no configuration necessary. Dedicated SQL pool can be changed manually or programmatically. And Spark, you can set up that auto scaling if you want when you initialize your cluster. As far as data lake support goes, serverless, you can query directly from your data lake. The dedicated pool, you can query data lake as well using Polybase. Just pardon me. You can query using Polybase, which is a technology to quickly load data from the data lake into Synapse. And with Spark, you can query directly from the data lake, of course. The last row here, Spark table support, not available in dedicated SQL pool, but can be queried in the other two options. So as you're thinking about your workloads, this is a good table to reference to help you decide which engine to use. All right, those are the kind of pools available. We're going to get into orchestration now. So Azure Synapse Analytics uses Azure Data Factory kind of embedded within it. It's not really referenced as Azure Data Factory within the Synapse workspace, but that's ultimately what it is. And Azure Data Factory is a service to orchestrate and operationalize processes. Some people call it code-free ETL or ELT as a service. It supports many disparate data sources and utilizes different compute services. Within Data Factory, you have pipelines. Just a second. Pipelines are data-driven workflows. They are a logical grouping of activities that perform a unit of work, and they can be chained together so that they operate sequentially, or they can run independently in parallel. I want to go over a couple concepts within Data Factory. The first is an activity. That's a processing step within a pipeline. Then a data flow. Data flow is an example of an activity, but it's important to call out on its own because it is a codeless Spark transformation. So if you want to get the power of Spark, but aren't yet ready to dive into coding in Scala or PySpark, you can get the power of Spark by using a data flow, which is kind of a visual representation of a Spark notebook. You can also call Spark notebooks directly, so custom notebooks that you've written, and also Databricks jobs. The next is data set. This maps to a data store. It's kind of like a pointer, and this is used in activities. You can think of this as like your source and your sink within an activity. Next is link service. This is analogous to a connection string. It's saved within the workspace. Sorry about that, I'm just getting a dry throat. A link service is analogous to a connection string and is saved within the workspace. So this would be like a connection string to any data source, whether it be Cosmos DB or your storage accounts within Azure or an Oracle database on-prem. That would be encapsulated within that link service. And then data sets would be on top of that link service. Then there's integration runtime. And this is the bridge between an activity and a link service. So when an activity runs, it needs a compute platform where either the activity itself runs or it gets dispatched from. And that's the integration runtime. So for instance, for a Spark job, the integration runtime would just be where the activity is kicked off from. Yeah, it's analogous in like SSIS, if you're familiar with that, the integration runtime there. All right, Data Factory is a pay-as-you-go serverless service, so you don't have to worry about spinning up or configuring any server that goes with it. There are triggers within Data Factory, which can be done manually. So you can manually trigger a pipeline, you can schedule a pipeline, or these can be event-based triggers. And there's robust monitoring. So you can see metrics about your past pipeline runs. All right, the last thing here, before we get into the hands-on section, I think, is source control. By default, everything you do in Synapse Analytics is saved within the service, and that's called Synapse Live. So all your scripts, pipelines, it's saved. You do what's called publish after you make changes to your SQL scripts or notebooks, and they'll be published to Synapse Live. But sometimes you may need a little bit more robust version control or integration with a Git workspace. So that's available to you. You can use Azure DevOps or GitHub or your own version of Git repositories, and that'll allow for some more collaboration. And there's some good documentation on this. I'll show that where this is when we get into the Synapse workspace. All right, now we're going to get into the hands-on section here. See if I can, oops, a little too far there. I'm going to stop sharing. Hope you guys can still see my desktop. I'm bringing up Visual Studio to show you an example of a workload in SQL that we're going to migrate over. So this example workload is just a simple SSIS package that is loading some data to a staging table. In this case, it's employee data. It's 10 CSV files. And we truncate that staging table, loop through each file. Oops, this is the wrong one. That's the one I want to show you a little later. Loop through each file, load with a DFT from the flat file into SQL. So this should be familiar to any data engineer that's worked in Microsoft SQL and SSIS. So it's loading this table. This is a database right on my local laptop here. The data is just an ID column, title, email address, first name, last name, and this is all pseudo data. None of this is real. So 10 files, 100,000 records each. It loops through and loads. I've loaded it already, but we can run it here. And just for demo's sake, and this could be scheduled, in SSIS with an agent job, run once a day, run once an hour, something like that. But you see it ran very fast, looped through each of those files, loaded it. Okay. So one thing you might think if you're familiar with this and you're not that familiar with Azure, well, to get it into Synapse, all I would need to do is maybe just change this destination to point from my local database, on-prem database, to the Azure Synapse Analytics, and that would work. And we will look at that in a second. But first, before we get into that, I'd like to just get into Synapse, give you guys kind of a tour. I'm not going to spend time today on going over how to create the resource itself. That's pretty well documented. I've already created the service itself. So this is the Synapse workspace. This is how you see it through the portal. You get a link to your workspace itself. Within here, you can see the SQL pools and Spark pools. You get a built-in serverless pool. Every workspace gets that. And then I created a small dedicated pool at the lowest tier of a DW100C. I also created a Spark pool. If there's time, we'll look at that, but we'll see how much time we have. So going into the workspace itself, this is the home page that you see. I don't really use the homepage that much. I kind of just jump into whatever I'm doing, but it can be good for new users. It has some quick links here. This will get you right into a copy data pipeline. This will get you to some documentation. This will get you, ready to build reports. One nice thing it has here is recent resources, so quick way to get to what you were just working on. The next tab here is the Data tab. This is where you're going to find your databases associated with this workspace. In this case, there's that small SQL pool that I mentioned that I created. And notice there's different icons here. These icons tell you what type of database it is. So in this case, this icon is the dedicated SQL pool. These two are the serverless pool. And then this is a Spark pool. This will look similar to you if you're familiar with SSMS. You know, you get your tables, your external tables, everything can expand here. You might notice some different icons here. This is indicating that distribution style within the dedicated pool. You can see this is round robin. You can kind of visualize that the data is distributed evenly. And you can do some actions here. So you can create, select top 100, create new tables, all sorts of stuff. You can create a Spark. You can load this data from the pool into a Spark data frame. You can start building data flows off of these data sets. So all sorts of stuff can be done here. There's also this link services tab where we're going to see any link services that we have. It's broken up into two categories. For instance, here we have the Azure Data Lake storage accounts. Here's the one that was created automatically with this Synapse Analytics workspace. And then we have the containers or file systems here. So this looks just like Azure Storage Explorer, if you're familiar with that. You can browse the data on your data lake. Then there's integration data sets. I talked about data sets in the Azure Data Factory section. So this is kind of like a pointer to data, and it describes the data, usually with the schema as well. Develop, this section is where you're going to find your saved SQL scripts, your notebooks, and data flows. You can create a folder structure in here if you'd like. So anything you do automatically will get created and ask you if you want to save it. You don't have to save it, but you probably want to save some of your scripts here. And then the integrate section is where you build those pipelines. So you can see I've got a couple pipelines here already created. We're going to go through pipeline creation here in a little bit. Here's where we would monitor everything. So any pipelines that have run, we can see some metrics about them, the duration, stuff like that. You can see the integration runtime that I have running. And then this is the Manage tab where you can manage your pools. So in here, I could create another dedicated SQL pool. You only get one serverless pool per workspace, but you can create as many dedicated pools as you'd like. And you can also pause, like I mentioned, the dedicated pool, or scale it from here. You can do that same pausing and scaling from the portal as well. So there's many ways to do this type of stuff. And again, you can do that programmatically as well. You can manage your Spark pools, your link services. Azure Purview is something relatively new brought in here. It's still in preview. This is a data cataloging service. We're not going to talk much about that today, but it's something to check out if you're starting in Synapse Analytics. You can manage your access to some security stuff here. And here's that source control management that I mentioned, so you can connect this to a repository. All right, so you saw the small pool. So if you're not that familiar with Azure and you had an on-prem package that was doing this, you might consider, well, I can just change that destination, and I've done that here, to point to that small pool. So you can add this as an ADO connection. You just give it the server name, your authentication, and the database name. In this case, I've named it small pool. And then you can map that in your DFT just like that. And that would work, but it is slow. Let's see if it runs. Actually, no, I'm gonna play it safe. It's been crashing in Windows 11 for me, so if I run one after another, it seems to crash. So I have to close it and reopen it. And that's just with debugging. If you're familiar with SSIS, you're familiar with crashing, especially when debugging a lot. All right, well, let's run this. So I've renamed this dedicated Synapse because that's a different sync here. You can see in the DFT what that looks like. Just that ADO.NET destination. It's mapped one-to-one. And oh, I should show you let me show you the table. So this is going into staging employees. And it has just the same structure there. One thing to note here is that if you're more comfortable with SSMS, you can load your dedicated pools here. So I showed you the server that I have running on my local laptop. Here's that connection into the dedicated SQL pool here. So you can see the same thing here. Make sure you're using the latest version of SSMS when you're doing this. Some of the earlier versions don't support everything that the latest versions do. And then we can go back here and run this. And we'll see that it runs a little bit slower because it's not using my fast SSD as the sink. It's using it's going over the internet and writing to the table on the dedicated pool. So I wouldn't recommend this method of migrating your workload. It might be something that is seems intuitive to you if you're so familiar with SSIS. But ultimately, what's happening here is these loads are going to be using like the older bulk load API to drop data into this sync table, and not some of the newer recommended methods, which I'm going to show here in a little bit. So see, it's running. It's going to get through it, but I'm just going to stop it. All right, we're kind of done with this SSIS package. So now in the cloud. So how would we do it in a more cloud native way? Well, first I would recommend that data is dropped directly in Azure on the data lake. So I don't know, for this example, this could be company internal data from some sort of, I don't know, HR system. And rather than drop it on a on-prem server, I would recommend having that data dropped into the storage account, specifically here within the data lake. But it could be any storage account within Azure. And so here's those 10 files we've been looking at. I've already uploaded them. I put, in this case, I manually just drag and drop those files into Azure Storage Explorer. So here they are. They're all using that hot access tier, so they're ready to be used. And I put them in this inbox folder. So from the home screen here, one way to load that data into our dedicated SQL pool would be to ingest that data using the copy data pipeline. So from the home page, you get this wizard. So this is probably the best first step into Synapse, especially transformations, is to use the copy data tool. They know that the copying data is a very common task that's done. So they've created this wizard around it here, and this will ultimately create a pipeline that runs the copy data activity. So we're going to build one here together. We're going to run it once here. Our source is going to be the data lake. And this connection exists already because it was built with the workspace. This is the one that comes with the workspace, but again, you could add another link service to any other data source. Our integration runtime, I spun that up beforehand. Sometimes you'll have to turn that on. It'll take 2 minutes to spin up, but I did that so we didn't have to wait for it. That'll allow us to browse our file system here, locate those files. I'm going to stop here at the directory because I want all the files to be loaded, and in this case it'll do it in parallel. We don't need recursion in this case. That would be if we had multiple subdirectories we needed it to traverse, and I think that's all we need to set here. Right now, this file format setting, it'll stay gray for a second as it actually interrogates those files and tries to determine what those files contain. In this case, it successfully determined that they're text format and that they're comma delimited and they're row delimiter. And it's also figured out that the first row looks like a header. So let's click preview data. Look, we can see that data here very quickly. Looks right to me. It's got all the columns. We can go into advanced. In this case, we don't have a backslash used as an escape character, but you might need those in yours. But there's also no quote character. And that's about it for this one. Now the destination in this case, we're loading to that dedicated SQL pool. So I go down and select it here. I select small pool. And this will give me the option of loading it to a new table. So why don't we do that? We'll call it webinar 1. And this will a table that'll be auto-created. You can also choose an existing table if you've already created one, but this is assuming this is the first time running through this transformation. All right. So here it shows the mapping, 1-to-1 in this case, no transformations here. Also gives you the option to run a pre-copy script. You might want to run that like truncate table statement here. In this case, we're creating a new table, so that would error out because this table doesn't yet exist. It won't exist until it's run the first time. So you come back and add that pre-copy script later on. All right, so then it asks just for a task name. I guess we can call it webinar task 1. And there's a lot more options. You can enable, more verbose logging, some more tables, staging tables. You can see that we have Polybase on here. So that's the technology we're going to be using to load that data in parallel. You can also configure the amount of processing used by this pipeline. We're just going to leave the defaults here for now. All right, so here's kind of the summary of what we're doing. And hit next. And now, so this is the wizard now creating what we've just told it to create. So it's going to create the data sets. It's going to create that pipeline, and then it's going to kick that pipeline off. All right, we got about 15 minutes left. I'm going to try to get through as much as I can here with you guys. All right, so that did that. So let's go into monitor. We'll go to pipeline runs. And we will make sure all of them are there. Actually, let's clean it up so we just see the one that I just created. There it is, it's in progress. So these pipelines have a little bit of spin up time. So while that's happening, I'll come back. It should take about 3 minutes to run this one, but we'll come back and look at that. But since we're running a little low on time, I'm going to jump over into develop, where we're going to take a look at a different way to load this data. In this case, using serverless. So using serverless, I have this SQL script already created. This is ultimately actually created dynamically. Actually, why don't I show you that? So you don't really have to remember all of this syntax. It's nice. You just go to the data, go in, and you say, bulk load, is that it? I can't remember the exact steps to get there, but you can create this. This was created dynamically from. It was from the table. That's what it was. So here, this is using the open row set syntax. We're specifying that there is a header, and so this will bring that serverless, bring that dynamic query processor to our data as it lives on the data lake, and give you that data. Look, within 1 second, we can query that data. So it might be that we don't even need to process this data much further, but let's see some examples of what we can do with serverless. So for example, here we can get a count by job title. So there we see the number of employees. That's an accountant, for instance. I mentioned we can create databases within serverless. So I've created this serverless employees database. That's how it showed up over there. You can also create views. So here's the view created using that same query, employees by title. You can also create stored procedures, and these can be much more complex. This is just very basic stuff here. But just wanted to show you what's possible with the serverless. All right, let's go back to monitor. Let's see if we've got this guy running. All right, it's in progress. Let's click into it though. So we see the copy data task is running. It's in progress. It's been going for 2 minutes. You can click these glasses here to see the details, kind of a nice visual representation of what's happening. Pulling that data out of a data lake store, loading it into the dedicated pool. We can see how many data integration units we're using. That's the measure of compute in Data Factory. We can see the parallelism, so 10, so that's one per file basically. It takes about 43 seconds to spin up, and it took about 2 minutes to write to the sink, so it looks like it's succeeded now. So that's how we could run it that way. So we're only got 10, 12 minutes left. I want to show you another way to load. So that's that is ultimately the recommended way for this loading into a dedicated pool, and that's using the copy into command. So this is recommended over polybase. Polybase previously was the recommended method, but this is now the recommended method. So you create the table, we can truncate that table, we can run this copy into command. I've left in a lot of the options here just to show you what's available with this copy into command. And then I've created a stored procedure to do those above steps. So in this case, SP load employees truncates the table, runs the copy into command. And then I've created a pipeline that runs that stored procedure. So this is the stored procedure activity within this pipeline. And when we run this one, we'll see that, let me take off this filter. See the demo pipeline there runs in about a minute, whereas the poly-based load took about 3 minutes. So you can see the difference in performance there. So just wanted to show you those different methods of loading that data. Again, the recommended method is to use that copy into, but it's not quite as easy. It requires some coding, whereas the poly-based one was just quick run through that wizard. All right, we got 11 minutes left. I'm going to quickly show you Spark, and then we'll use the remaining time for any questions that come in. Okay, so Spark is really powerful, like I said, and you can access it very easily by just going to create new notebook on that data and say load to data frame, and that'll prime your code here. So this will help you if you're brand new to Spark. Spark.read.load, the location of the file. In this case, I just clicked on that one file, but you can replace it with wildcards. We know there is a header, so I'm going to uncomment that row and run this. I need to specify my pool. You can run it with Control Enter, just like other notebooks, and it'll take a couple minutes to spin up that server and run. But this will just show you that data, and this would be a good jumping off point to writing your notebook. You also have the ability to add in Markdown, to document your notebook. All right, let's go back to that monitor. Yep, so this task finished in about 3 minutes. I didn't run this one with you guys, but I ran it before the class, and it took about 1 minute. We can also look at this Spark pool as it's spinning up here. Yeah, it's not yet up yet. But that's a good overview of Synapse, everything that's available to you. I haven't been watching to see if any questions have come in. Doesn't look like any questions, but feel free to ask some questions now and I'll get to them in the remaining time. right, I don't see any questions coming in. Martha and Rachel, let me know if you see them, any that I'm missing. All right, well, this job just finished, so you can see the
Hey,
data.
Matt,
Just yeah.
somebody was asking if you can recommend any books or online tutorials for this.
I don't really have any recommendations for books or online tutorials. I guess the learning path within Microsoft is a good thing to consult. I think that's like learn.microsoft.com. There's the two classes, DP 200 and 201, which are the data engineer associate classes, I believe. Those are very good. Just the regular Microsoft documentation is actually very good. So I would just recommend reading through it. It's all open source and hosted on GitHub. So if you want more information on a specific section that's not well documented there, you can request it on GitHub. For Spark, I can recommend a couple books for Spark specifically. Let me just get those up. For Spark, I would recommend Spark, the Definitive Guide, Big Data Processing Made Simple by O'Reilly, and that's by Bill Chambers. And then also Learning Spark, Second Edition, another O'Reilly book. That's by Jules Damji and Brooke Wenig. So those are two really good Spark books that I've read and would recommend.
I think that's it.
I see one more question. It says, any performance considerations on ETLs transferring data between on-premises and Azure cloud?
Okay, good. Yeah, that's a good question. So I meant to mention something about this. Yeah, so this presentation, this webinar, I've gone primarily over the components and trying to help you as you make your decision on how to move your workloads that, which service within Synapse to use. But as far as migrating the data itself, so let's say you have a data warehouse on-prem and you want to move all that data, Microsoft has provided a tool called Synapse Pathway, and that's for three different sources of data, one being Microsoft SQL Server, the other being IBM Netezza, and the third being Snowflake. And what that does is it analyzes your source data and it'll run a full report on it and tell you what of your data, so your table data, your stored procedures, your views, everything, what will work just kind of out of the box in a dedicated pool. And it'll tell you also what can be automatically transformed. So I mentioned there's syntax differences. So this tool will also try to update your syntax and like your stored procedures to be conformant with the dedicated SQL pool. And it'll tell you what areas need manual attention and can't be easily migrated. And then it'll give you a good path to migrate that data over. And how you move the data over is really kind of dependent on the data itself, how big it is. There's a number of different options, but I meant to mention that Azure Path or Synapse Pathway.
Okay, that does look like the last question.
All right. Well, thank you everybody for joining. You can send further questions here to webinar@wintellect.com. Thank you for joining.